Hi students, this is Algebraic Proportions. If you were with me for pre-algebra, we did cover this in pre-algebra, and so for some of you this will be very much review, so it might seem like an easy lesson. And for some of you who've stepped away from math for a while, this may be the first time that you've seen it. Or it may have just been a while. So proportions, remember, are fractions that represent equivalent ratios, and when that is the case, then the cross products, which is the diagonals, have to be equal to one another. And so sometimes the problem can be as easy as number 1, where we simply cross multiply and divide because that's the only step. There's no need to distribute. But typically we will have to cross multiply and distribute, whether we do that as part of the same step or we write it down with parentheses first. There will always be an equal sign in between our cross products. That's setting them equal to one another. And then we're going to have to get our variables on the same side, add or subtract, and then divide, provided that there might be more than one variable, or the variable might appear in more than one place, I should say. So here for number 1, the first couple are going to be easier, and then they're going to get into the ones that are more like our true algebraic proportions that have multiple steps. So again, we're crisscross, cross multiplying, so not across the equal but diagonal. So 6 times 4 is 24. That's equal to, now I'm going to go the other direction, 3 times x, 3x, and then we can simply divide both sides by 3, and we find out that, of course, x is equal to 8. Like any equation, you could plug it in to make sure that it works. 4 over 3 is equal to 8 over 6. And we can see that those are equivalent fractions because the one on the left is just multiplied by 2 to get to the one on the right, numerator and denominator, so it checks out. Or another way to check is once you have it to this point, take the top number, divide it by the bottom number. In this case, we would get 1.3 repeating, and we would get 1.3 repeating on the right also. So that one's very straightforward, like solving just a regular proportion, and would probably not, like you could probably solve it without actually going through the steps. Starts getting a little harder in number 2. We are going to have to start distributing in number 2. So again, crisscross. So these two are going to get multiplied. So 2 times n plus 5 is going to be equal to, and then these two get multiplied, 4 times 10. And I'm just going to go ahead and write down 40. In fact, as long as you'll remember to distribute, you could have done 2 times n and then 2 times 5, and kind of distribute it as you wrote down the problem, as you wrote down your cross product, which could potentially mean skipping that step. But if you find yourself accidentally writing down 2n plus 5, go back to using the parentheses, and then from there, of course, we are just back to our usual 2-step equation, and then I'll divide by 2, and n is 15. And again, I did not write divide by 2, but you certainly can still draw the fraction bar, divide by 2 on both sides. So n is 15. If I plug that in to check it, I would have 2 over 10 equals 4 over 15 plus 5 is 20. So 2 over 10 is equal to 4 over 20. Again, in this case, they're top and bottom are both just multiplied by 2, so it's easy to visualize that they are equivalent. So getting a little harder, we're going to kind of work into ones where we have more than one variable. So let's move on down here to this next ones. Yeah, so in 3 and 4, we have more than one variable. So let me make this a little bigger so I have lots of space. Hopefully you have found this page in your packet. It is page 7. All right, so it is page 7, and at least this point, my plan is that this will be on day 2. So things could change, but the instruction part doesn't change, just perhaps when I'm doing something. All right, so that gives me plenty of workspace. So again, cross multiply. And so this time when I cross multiply, I'm going to try to just like distribute as I go. So, and if one of them is just a number like that 5, think of it kind of being on the left, you know, like you're distributing. So 5 times y, 5y, 5 times -3, -15 is equal to 2 times y, 2y. Now, typically, it's typically my habit to put my variables on the left. If I do that in this case, I'm going to have one additional step because there are no constants on the right. So since there are no constants on the right, I'm going to make the right-hand side my variable side for a change. If you did it the other way, you should still get the same answer as long as you remember to move your constant. You don't want everything on the same side. So that gives me -3y. Then we can divide both sides by -3 and get 5 is equal to y. What you want to be sure that you don't do is move the 2y over to the 5y and then divide while things are on the same side of the equal sign. All right, so you could do that, but you would have to add 15 to move it to the other side if you put it on the other side. So just a little bit shorter in this case, since I don't have any constants on the right, if I move my variables to that side. All right, number 5. Excuse my sniffliness today. Not sure exactly, allergy season. So we're going to cross multiply again. So 5 times both of these. It's like it's in parentheses because that fraction bar does create a grouping symbol. So 5 times 2k makes 10k. And 5 times -3, -15 equal, because there's always going to be an equal in the middle, and then I'll go the other way, 3 times k, 3k, 3 times 9, so plus 27. Now, of course, we have to get our variables on the same side, so we're going to move a variable. I'll move this 3k by subtracting 3k. Now I have 7k minus 15 is equal to 27. And we're just to that two-step equation. We'll add 15. Again, the things I'm writing right now, I didn't use my color as normal on the last one, but the things I'm writing right now, if you just showed me what I'm writing in black, I would still consider that you are showing me your work. What I'm writing in blue could just be thinking steps, that we add 15, that we move a variable by subtracting the 3k. We add 15 to move the constant to the other side, and then we divide by 7 to get our final answer. So k is equal to 6. And if I plug that in, 2 times 6, so this is what I would be doing, 2 times 6 minus 3 over 6 plus 9 should equal 3 over 5. Now, doesn't mean it's going to be 3 and 5, but it would be an equivalent fraction. So 2 times 6 is 12, 12 minus 3 is 9, 6 plus 9 is 15, and hopefully you recognize that if you reduced 9 over 15 by dividing top and bottom by 3, you would get 3 over 5. Or if you divide both of those fractions on your calculator, they are both equal to 0.6. And so that is what I will be asking students to practice for this lesson. There is not a separate page that is labeled homework since we're going through this as a bit of review. So if you are at home working on this, if you would just work on the evens in the you try section. So that is the front and back of this page, just the evens though. So we're talking about 8 problems. All right, thanks. Again, that's algebraic proportions. Please give me a yell if you have questions.